Alright guys, we kind of looked at doing some string comparisons here, and we saw those single and double square brackets, okay? Something else that we can do is actually use the test command, which is synonymous with square brackets, okay? Because those square brackets are just test statements, right? We're testing to see if one thing is equal to, less than, or not equal to another thing, right? So that's what we can do with test here. So the test command is a bash built-in which tests file types and compares strings. Therefore, in a bash script, test does not call the external user bin test binary, which is part of the shell utils package. Okay, so we see some examples down here. So we have test 5 equal to 5 and echo yes or echo no. Okay, so this can be read also as almost like a if-then statement. So if 5 is equal to 5, then echo yes, else echo no, right? We can even try that here. We don't even have to write a script for this. We can just do this on the command line. So we do test first, then the number 5, dash EQ, which stands for equal to, okay, 5. So test if 5 is equal to 5, double ampersand sign, echo, yes. Then we do a double pipe, echo, no. So test 5 is equal to 5 and echo yes or echo no. So if we hit enter, 5 is equal to 5, so we should see yes. And sure enough, we do. Okay. If we go back to our PowerPoint, we see another one. Test 5 is equal to 15 and echo yes or no. Okay. So test 5 dash EQ for equal 15, double ampersand symbol and echo yes or echo no. Well, 5 is not equal to 15, so we should see a no. And sure enough, we get no. We look at our next one. Test 5-NE, which is not equal to 10, and echo yes, else echo no. So test 5-NE for not equal 10, and double ampersand sign, echo yes or echo no. Okay. Obviously 5 is not equal to 10, so it echoed yes. Next we have another one that's actually just testing to see if it's a file. Okay. So we have a test-f, which is file, and then we put in a file. If it finds that file, it's going to echo file found. Otherwise, it's going to echo file not found. Okay. So let's try that. Okay. Real quick, before we do that, let's actually do a cat etc/resolve.conf. Well, that file does exist. Okay. Okay. By the way, this file is how you do DNS. This is where you set up some of your DNS servers. Okay, but that's besides the point right now. But we know that file exists now, right? So if I do a test-f on /etc/resolve.conf, so I'm seeing if this file exists. If it does, echo file /etc/resolve.conf found, or echo file /etc/resolve.conf not found. Okay. And I need to actually double check I wrote everything in here. I did not. Okay. So this would have failed because I spelled this wrong. There we go. So you always want to double check what you put in to make sure it's exactly what you want. And that looks right, so I'm going to hit enter. Oops. I see what I forgot to put. You guys catch it? I forgot to put a parentheses at the end, so that's also important. There we go. Looks like I had several errors here, guys. Too bad you can't be here to catch me when I put these typos in. There we go. Let's make sure there's no more spelling errors here. Okay, so it says Etsy resolve.conf not found. Okay, so echoed that second part there. So if I go back to our PowerPoint, we can see the last one, they put a number 1 at the end of it. And obviously that would echo file not found because that file doesn't exist, right? So that's kind of how you can use the test statement. You can test certain statements out. You don't even have to write a shell script for it. So let's go ahead and move on with our PowerPoints. We're going to talk about numeric conditions, okay? I'm going to actually write these out for you guys. So the first one we're looking at here, we're using the P command, or the read command, which, if you remember, takes user input, stores it in the variable you assign, and then you can use that variable in whatever input you get from the user. Now, in this example, we're using a little bit different. We're putting read first with the -p option, and then we're putting the variable at the end. So we're naming the variable in here in this case, okay? And that's where you're going to see this variable come from in. So it's taking user input, storing it in, and then it's being called there, okay? So we're going to see if n is equal to 10, then we echo thanks for entering number 10. So let's go ahead and do that. Oops. So let's make a script called them number.sh. Insert mode, we always start every single script with our hash pling. So we're going to use bin bash in this case. We're going to do read-p. Say please enter and confirm number 10 via keyboard. Okay. Oops. And we're leaving a little bit of space here. So remember, this is a literal string, so it's literally going to type in this colon, a space, and then we're ending it. So we want that space after the colon just so it looks a little bit nicer. Then we're going to store that value in n. Okay. Oh, I'm doing all sorts of typos today, guys. There we go. Right there. Please enter number 10. There we go. So we do if test. So we're using that test statement again instead of square brackets here. Variable n is equal to 10, then echo thanks for entering number 10. Okay, so we're doing an if statement there. Instead of using brackets, we're using the test command. Okay, and then we do then, which is in line with the if statement, and then we do echo. Okay, and then we want to end it here, so we put phi, which is the reverse of if. That's how we end an if-then statement. So if this is true, then echo this, end. Okay, so if n is equal to 10, echo this. And in this case, it's going to ask us for some input. So I need to make that executable so I can run it, right? And then I'm going to go ahead and run it with // so look in this directory and run number.sh. It's asking me to please enter and confirm number 10 via keyboard. Okay, sure, I'll put in 10. Thanks for entering number 10. I spelled entering wrong. I can't spell today, apparently. If I run that script again, I put 9. See, we didn't put up a statement or a way to exit out of that in case someone doesn't put a 10. But you see, it just doesn't enter anything, right? Because we didn't tell it what to do if someone entered anything but 10. So that's the first one, first numeric condition. Next, we're going to look at less than, or -lt. Okay, so we're going to go back to that script. Oops. Back in our script, we're going to set up another if-then statement. So if, or we're going to do read again. So read dash p, do not enter negative number here. So if variable in, oops, we put the test statement. So if test variable in dash lt for less than 0, then echo. Oops, that should be indented. There we go. Echo. Damn. You entered a negative number. How could you? We asked you not to. And then phi, because we always end our if statements with phi, right? Now I'm actually going to put some space in between these if statements so it looks a little bit nicer. Oops, there we go. Yeah, so there's some space here. Okay, we're going to write quit. We don't need to make it executable, right, because we already did that, so we're just going to execute it. Please enter a number, confirm 10 via keyboard. Sure, 10. Do not enter a negative number here. Well, I'm not going to listen. I'm going to enter a negative number, negative 5. Damn, you entered a negative number. Well, I sure did, right? So we know our script worked. Next, we're going to look at the dash LE, which is less than or equal to. Okay, so I'm going to enter that script again. I'm going to start up another if-then statement. So if, or I'm sorry, I'm going to do a read command first, dash P. So enter backup level. And actually, if some of you took some of our previous courses, you'll be familiar with backup levels. We're going to store that value into variable n. Okay, so if test statement variable n is dash LE less than or equal to 6, then echo incremental backup requested. REQUSTED. Okay. Phi. Always in our statements, if statements with a phi. So we're testing to see if n is less than or equal to 6. So I could put 6 and it would still be true, or I could put anything less than 6 and it would still be true. Okay. Let's go and do a right quit. We're going to run that script again. Please enter number 10. Number 10. Please do not enter negative number here. I'm not going to listen. Negative 5. Enter backup level. I'm going to hit 6, and because it's equal to 6, remember less than or equal to 6, it should still be true, and we should still see the echo message. Perfect. Sure enough, we see that echo message. Okay. I'm going to clear my screen just so we get a little bit of space back here. And we're going to look at our last numeric condition comparison, which is going to be dash NE for not equal. I'm sorry, dash EQ for equal. Okay. Oops. If test $n is dash EQ to 7, then echo. Let me move my screen up here so you can see everything I'm typing in. Echo full backup requested. Phi. Okay. So let's run that script and see what happens. Please enter number 10. Sure. Do not enter negative number. I'm not going to listen. Negative number. Take that. Enter backup level. Hey, this time I'm actually going to type in a 3 just so you can see that it's less than or equal to 6 and it'll still become true. Sure enough. Okay. So guys, what happened here? Didn't ask for a message this time, right? Well, that's because we didn't use the read statement, right? So if I run that script again, and this time I put 7 here, oops, you see it didn't echo that first message, but it did echo that second message, right? And that's because we have two different if and test statements here. So if oops, keep control of my mouse here, there we go. So if n is less than or equal to 6, then echo this. Then we set up a whole other statement and said if test variable n is equal to 7, then echo this. And we typed in 7. So this wasn't true, so it skipped this. It didn't echo this. This was true, though, so I echoed this. And we didn't even have to use the read command because we're using the same variable in all of these. Okay. If I would have put 7 anywhere else on here, it would have echoed this after it went through all these, right? Because it goes one by one, line by line. Okay.